I'm hearing all the stuff in my ear, making beeping sounds. Okay, so sequences. This chapter is sequences and series. Today's sequences, right? And they have their own SOL. It's number 2. Most of this stuff will make more sense when we get to the end of the lesson here. A sequence, I'll just define it. A sequence is an ordered list of numbers. That's the definition. These are a few examples of sequences. By ordered, it means 2468 is a different list than 8642. If you change the order, it's not the same sequence anymore, right? So each number has a position. There's a first term and there's a second term and there's a third term and a fourth term. That's what we mean by ordered list of numbers. Thought I closed this already. Okay. So an infinite sequence has infinitely many terms in it, and you see it because it got the dot, dot, dot at the end. Right? That means that that's going to go on forever. If there's a pattern, and there's not necessarily a pattern, that just means that pattern goes on forever. Okay. Good. All right. A finite sequence has a countable number of terms. It doesn't have any dot, dot, dots at the end. So you see that there? Because there's no dot, dot, dot. That is the sequence. Doesn't keep going. There's no next term. Good. Slow me down if it's too much. Okay. Individual terms in a sequence are represented by a lowercase letter a with a subscript. So a with a subscript of 1 means the first term. A with a subscript of 2 is the second term. A with a subscript of 3 is the third term. Okay. What if I said in this one right here, right? What is A4? Right? It would mean A4 would be the 4th term in the sequence. So you would go over it, and the value that's in that spot, that's it, 8. What is A2 in this one? It's 4. Right? So that's how we refer to any particular term in the sequence, A sub, and then it's what I would call the ordinal number. Right? First, second, third, fourth, fifth. Good? Ashley, Burton? Okay. Now, if you notice in each one of these, there actually is a pattern. And if you could write a formula that represented the pattern, that would be the formula for the nth term. And it goes by A sub n. So for example, if n represents the number of the ordinal number of the term in the sequence, then this one right here, 2, 4, 6, 8, the formula for the A sub n would be 2n. Right? If you plug in the n, you get the value that's in that position. Right? If I plug in n equals 3 for the third term, 2 times 3 is 6. What about the third one? Does anybody see the pattern that's going on in the third one? Curtis? It's n squared, right? These are the perfect squares. So n squared. Now, who knows who could come up with a formula for the second sequence? A sub n for the second sequence. What does it look like is going on there? It looks like you're just doubling it, right? So every term has one more factor of 2. And you know how you make that happen? Is you're gonna raise 2 to a power. That way, every time n is one more, you get one more factor of 2. But would 2 to the n generate that sequence? What would happen if you plug in n equals 1? What would be the first term? But it's not. It's 1. So this one actually is 2 to the n minus 1. Now, when you plug in n equals 1, you get 2 to the 0, and anything to the 0 is 1. When you plug in n equals 2, you get 2 to the first, and there's your 2. So it's actually 2 to the n minus 1. So these are all formulas for the nth term in the sequence. Sure.
So what about when you plug in 4? That would not look like
2 to the 4 minus 1 is 2 to the third, which is 8. Right? So the fourth term is 8. A4 is 2 to the third. 2 to the third is 8.
Oh, okay.
Okay? So A sub n, that formula for the nth term. Now, a particular pattern for a particular sequence is called arithmetic. Right? It looks like the word arithmetic, but you say arithmetic. An arithmetic sequence, the technical definition is a sequence in which the difference between consecutive terms is constant. You know, what you see is that it looks like you keep adding the same number to get the next term. That's arithmetic. So which one of those was arithmetic? The first one, right? The first one is the one where it looks like you keep adding 2. Okay, so this one is the arithmetic. Now, if you go back to their definition, the technical definition is the difference between consecutive terms is constant. 4 minus 2, consecutive terms means in a row, right? So 4 minus 2 is 2. 6 minus 4 is 2. 8 minus 6 is 2. You're always subtracting the second term or the term after by the one before it, right? Because what would happen if I changed the direction? If I get 2 minus 4, I would get negative 2, right? And that's not what's going on. So it's always the second term minus the first, the third minus the second. And if in every case that's the same number, then it's arithmetic. What about these two? Any chance that they're also arithmetic? No, the first 2 minus 1, 1. 4 minus 2, 2. Okay, so it doesn't even go 2 terms, so we have to stop it. How about this one? 4 minus 1, 3. 9 minus 4, 5. No, so the only one was this one right here. That's the arithmetic. Okay, if there is a constant difference between the terms, right, the number you keep adding to get the next term, it has a vocabulary word for it, right? Common difference, right? That constant that you keep adding to get the next term is called the common difference. And we use the lowercase letter d to represent the common difference. So what are all the things that we have letters for now? D is the common difference. N is the number of the term, or the ordinal number of the term. A is the value of the term, right? So those are all the things. Okay, so usually these kinds of questions, and I think in the homework, it says, is the sequence arithmetic? And then it says, and what is the common difference? So we'll do that too. Is this arithmetic? Okay, and what is the common difference? I mean, it looks like 6 minus 3 is 3. Right? 9 minus 6 is 3. 12 minus 9 is 3, etc. 15 minus 12 is 3. You know, if that last number was 16, you'd have to go back and say it's not arithmetic, right? It's got to be constant for every difference of consecutive terms. So you would say that D equals 3. Good. Okay, so you guys, this would be your you try. Check those two out. If they're arithmetic, what is the common difference? I'll give you maybe 15 seconds. Go ahead. So was the first one arithmetic? No. So 4 minus 2 is 2. 8 minus 4 is 4. So not arithmetic. How about the second one? Okay. So 5 minus 1, 4. 9 minus 5, 4, etc., etc. So yes, arithmetic. What is the common difference? Okay, if, you know, we don't have a lot of examples that we're looking at, you'll get more in the homework, but what if that sequence of numbers instead was 17, 13, 9, 5, 1? What would be the common difference? It would be negative, right? If the terms are getting less, you're adding a negative number. D is negative. And when we take the SOLs, there are formulas for most of this stuff. Not this, but we're going to introduce the next formula on the next slide. You're given all the formulas, and you'll be given them in our test because, hey, they're going to be given to you on the SOL. Good. Right, so the formula for the nth term of an arithmetic sequence is found by this formula. A sub n, the nth term, right, equals a1 plus n minus 1 times d. What does the a1 represent? First term. And the d is common difference. So in order to have a formula, you're going to plug in for the a1 and the d. Substitute for first term and common difference. You don't plug in, if you want a formula for the nth term, you're not going to fill in for the n. You need to have an n there because that'll be where you plug in to find whatever term you want. If you want a 100th term, plug in n equals 100. If you want the 50th term, plug in n equals 50. But we do need to plug in for the A1 and the D. So what is the 100th term of an arithmetic sequence that begins with 6, 11? And I'll say that first, this one does not say this, right? But most of the time, these kinds of questions say, find the formula for the nth term, and then find the 100th term. This one doesn't really say that, but I'm going to do that first, right? First, find the formula. Find formula for nth term. Okay, start with what we just did on the last slide. AN equals A1 plus n minus 1 times D. Okay, now from these two numbers, can we tell A1 and D? What is A1? 6, right? There's the A1. And what is the D? And the D is 5. So again, that's all you need to plug in here. AN equals 6 plus n minus 1 times 5. And that should be simplified. AN equals 6 plus 5n minus 5. AN equals 5n plus 1. That's the formula for the nth term. Now, for arithmetic, that's the general look of a formula for an arithmetic sequence. It looks linear. It's kind of like mx plus b. That is arithmetic. Okay. Second, find A100. So how are we going to find A100? Given this formula, how do we find A100? Plug in 100 for n, right? So A100 equals 5 times 100 plus 1. A100 equals 501. I guarantee you, if I have the same question on a test, several of you will just start writing out 100 terms, adding 5 every time. The point is to use a formula, but some will always do that. Even in pre-cal, you look on the back side of the test and they've gone from one top corner all the way down to the bottom to find a number that they could have found pretty easily just using the formula. What's that? This? It said find the 100th term. That's the 100th term, 501. There's nothing less to solve. What would you solve for? Do you see any variables here?
I forgot that the subscript of A was the term.
Yeah. I mean, if you compare, this could be like function notation, right? When we deal with polynomials, this could be like f of x equals 5x plus 1. Right? I mean, if I plug in the same values of x, I would get the f of x values would be the same as the a to the n. What would be the difference between the output of this one and the output of that one? Could you plug in 1/2 for n here? No, it has to be countable numbers, right? But you could plug in a 1/2 for x. You know, the graph of a polynomial is a continuous, smooth, continuous line. The graph of this thing is a bunch of dots. They could be connected with a smooth line, but they're really not. The sequence is just those individual dots. You know, plugging in, if you evaluate a function by plugging in a value for x, like f of 100, you would plug in 100. That's what a sub n is. It's just like function note. It just means plug in n equals 100. Okay, so you try to do the same thing. Find the 46th term of a sequence that begins, arithmetic sequence that begins 3, 5, 7. Got it? What is it? A46 is 93. How many got 93? How many got 91? Everybody get 93? Who didn't get 93? 93. The answer is 93. That is right. A46 is 93. Again, if I have to start with this. AN equals A1 plus N minus 1 times D. Right. I'm going to plug in for the first term, which is 3, and the difference looks like 2. Now, if all you're being asked is for the 46th term, you might have at this step just plug in for the n at the same time. You weren't asked for a formula. But just be careful. If it asks for a formula, you need a formula. You can't just like in one step do A46 equals 3 plus 46 minus 1 times 2. If you did that, you just skipped half the problem. Right? But for this problem, it didn't ask for that. A46 equals 3 plus 45 times 2, which is 93. What do you think? Easy? Yeah, I think today you probably won't find that hard, and then next class you might find a little harder. We introduce some more symbols that you're probably not familiar with. Right, now we jump to the next section, which is the 9-3, geometric sequence. So the definition of a geometric sequence is a sequence in which the ratio between consecutive terms, not the difference, the ratio. And what it looks like to you is it looks like you keep multiplying by the same number. So which one of those is geometric? The second one, right? Because what does it look like you're multiplying by to get the next term? You know, it looks like you're multiplying times 2. So this one, 2 times 1 is 2, right? Or if you did it in terms of the definition, 2 over 1, 4 over 2, 8 over 4. That's the ratio of consecutive terms, 16 over 8. Every case, it's 2. So this is the geometric. You know, any chance that the third one is geometric? No. And we've already checked the first one, but 4 over 1, 9 over 4, no, it's not constant. Okay, if it's geometric, that constant ratio is called the common ratio, and it goes by the lowercase letter r. Right. So for arithmetic, you got D. For geometric, you've got R. So would you say that that is a geometric sequence? Okay. What does it look like you keep multiplying by to get the next term? 2. So 6 over 3, 12 over 6, 24 over 12, and 48 over 24. In every case, equals 2. So yes, this is geometric. R equals 2. I mean, you could tell, since R is a number bigger than 1, the terms are getting bigger. Okay? If you wanted the terms to get smaller, then you'd multiply by a number less than 1, like 1/2. And that can happen. We didn't say the A1 part, but that's kind of obvious. So you do those two again. Which one is geometric? What is R? I wonder if I neglected to copy something here. 9, 3. No, that was the same. So which was the geometric? A. Right. We did this one before. That was arithmetic. And the common ratio is? So geometric. R equals 2. I mean, it makes the point, not very challenging. Okay, so next, we need a formula. Formula for what? For the nth term, right? We need a formula for the nth term of the geometric sequence, and that is that. AN equals A1 times R to the n minus 1. So we know the AN means the formula for the nth term. The A1 is the first term. The R is the common ratio. The N is the ordinal number of the term. You know, as an example, I could say AN equals 3 times 4 to the n minus 1. Now, one thing you got to watch, because this is a common mistake, you can't multiply in this example. You cannot multiply 3 times 4. Do not turn that into a 12. I mean, this is properties of exponents. 3 is not being raised to the same power as 4. It's a number in front of the 4 to the n minus 1. So don't fall for the trap of multiplying those two. You can't. And then if you remember when we looked at the formula for the nth term of arithmetic, we said it looked linear. If you look at the formula for the nth term of a geometric, it looks exponential because the n is in the exponent.
So if it actually was to ask you for the formula to find the term,
What do you mean?
like you said, if we can't put n in if it wants us to find the formula.
Yeah.
So
Well, if you're given the A1 and the R, you plug them in and you stop. You're done. If it says find the 46th term in the sequence, then you could also plug in n equals 46, right? It just depends what they ask for. I think the first thing we'll do is like this: find the 10th term in this geometric sequence. Right? An equals A1 times R to the n minus 1. Now, you won't want to, I don't know if it confuses people at all, the use of parentheses here, but, you know, that's a multiplication too. And just in case nobody's noticed this since September, but whenever you're doing a problem, there's a formula involved. I mean, personally, I write down the formula. Before I start trying to plug things in, write it down the way you're going to use it. Then you start plugging things in. Okay, so we have to plug in two things here. We have to plug in for the first term and for the common ratio. Okay, can we tell what they are by looking at these three numbers? The first term is 4. The R is 3. I mean, it's pretty easy to tell them both. A1 and then 12 over 4 is 3. That's R. So plug that in. An equals 4 times 3 to the n minus 1. Now we can find the 10th term. How do you find the 10th term? Put in n equals 10. Okay, so A10 equals 4 times 3 to the 10 minus 1. A10 equals 4 times 3 to the 9th. So that you have to put in the calculator, if you have one. What do I do with my calculator? Let me see. 78732. Okay, 78732. Where is my calculator? Yeah, it's right there. It's right in front of me. Couldn't be any more obvious. So easy stuff? No. Back to square one. That's it. Back to the drawing board. What's that? 78,732. Do you not get that? Got to multiply times 4. 4 times 3 to the 9th. Good, Sandy? Okay, so try to do the same thing here. Find the 10th term of the sequence. Notice that the second number is negative. We got answers? It's Trevor.
Negative 39,366.
Who agrees with that? Negative 39,366. Anybody disagree? Curtis did in his head, right? Yeah. Again, write down the formula. AN equals A1R to the N minus 1. AN equals, A1 is 2, and now R, negative 6 over 2 is negative 3, right? It's negative, which means it's going to alternate signs. Every other term will, or every term switches sign. So that's negative 3 to the 10 minus 1. AN equals 2 times negative 3 to the 9th, which is negative 39,366. And we agreed that we had 100% got that right, correct? 100%. Okay? Find the 15th term. Use the same formula, find the 15th term. And I guarantee you, we will not all get it right. I will bet you. What's that? Yeah. Find the 15th term. Morgan, you there?
Yeah.
Oh, okay. Looked like you were zoned out. Who's going to be the first to offer up their answer? You said negative 9,565,938. How many agree with Rebecca? How many? Okay, you're all wrong.
Oh, I think
What is it?
is it positive?
It's positive. Okay, so notice what happens here when I say AN, and undo. Right, A15 equals 2 times negative 3 to the 15 minus 1, 14, right? Turn that on. If you didn't put the negative 3 in parentheses before you raised it to a power, it's wrong because it's not taking the negative to the 14th power. When you take a negative to an even power, it's going to be positive. So we didn't have the same issue here because we were finding the 10th term, which means we raised it to an odd power. And when you raise a negative number to an odd power, it's negative. It is right to do that. It wouldn't matter if it's in parentheses or not. But you should be careful of that. If you're raising it to an even power, you need parentheses around that. So it should have been negative or positive 9,565,938. Now, that was interesting. Yeah. The answer is positive. If you got negative, you didn't put the negative 3 in parentheses. Remember, another thing you could do, which is I like to do it this way sometimes, especially like in the next lesson when we're doing what's called the series, is if you would, in the calculator, store, for A, use A for A1, and store 2 store A, and then do negative 3 store R, and then and N, 15 store N, and then just type in the formula. A times R to the N minus 1. And it'll take care of that. You'll never have a problem with that, with the sign. Okay. So there's going to be some homework problems like this. They didn't have any examples, so I'm just going to show one like this. It says write the explicit formula. And I wish it was a little bit out of order. By explicit formula, we mean the one that we're using. Okay. So AN equals A1 R to the N minus 1. Bye. So plug in for the A1, plug in for the R, right? That's the easy part. And this says make the first 5 terms. Well, you already have the first term. Right? How are you going to find the second term? What's that? No, you're probably right. I mean, if you want to find the second term and you have a formula for the nth term, you plug in n equals 2 and calculate. What else could you do? If you want the second term, A2, you plug in n equals 2, right? But if you know that the first term is 4 and you want the second term, multiply by R, right? So what is 0.1 times 4? 0.4. It's like multiplying by 1/10, right? It moves the decimal place over 1. What if you multiply? What if you wanted the next term? It'd be 0.04, right? It would just keep moving the decimal place. So every time you multiply by 0.1, it moves the decimal place over 1. I mean, you can plug in, for n equals 2, 3, 4, and 5 and calculate. Just use that and calculate. Or you could just keep multiplying here until you get it. 0.004, 0.0004. Done. There's your first 5 terms. A lot of times it's easier just to keep multiplying by R than it is to keep plugging into the formula, but it's up to you. And you can always use a calculator. In fact, the calculator has a mode for sequence. If you go to the mode and look, mode, and if you go to the 4th line down, it's probably highlighted on function, F-U-N-C, and all the way in the right, it's sequence. If you go down to that row and highlight sequence and enter, and then go back to y equals and see what you see. I never even 100% understood what I'm looking at when I look at this, I have to tell you. That is a way you could enter in sequences directly. I mean, in the end, you might as well just do it in a regular function mode and put in 4 times 0.1 to the x minus 1, and then look it up in the table for the integer values. You'd have the same thing. Okay, so do the same thing with this. Write the formula and the first 5 terms.
So what's it? Geometric?
See the R? If it has an R, it's geometric. What was the formula? AN equals 1 times 0.5 to the n minus 1. That's the formula. Okay, if the first term is 1, what's the second term? 0.5. In fact, if you could leave it as a decimal. What if you left it as a fraction? I think it would actually go easier, right? If I've said the second term is 1/2, and R is 1/2, right? Then what's the third term? 1/2 times 1/2 is 1/4. What is the next term? 1/4 times 1/2, 1/8, right? 1/8 times 1/2, 1/16, right? If you did it as decimals, then 1.5, 0.25, 0.125, and I think it's what, 0.0625? Either way. Okay. Come on, go. So there's actually two kinds of formulas, and on the formula sheet they've got them both. Most of what we do is with what they're called the explicit formulas, the ones we already did in class today. But there's there's another kind of formula, one for arithmetic and one for geometric, which is called recursive. And these tend to confuse us a lot when we deal with recursive formulas. And I know it has to do with using, and if I say an plus 1 equals an plus d, it's too abstract. But again, if you're talking about A represents the terms in a sequence, understand that the nth term is the term that comes right before the nth plus 1 term, right? And what would come right before the an term? The an minus 1, right? So these subscripts are just saying these are the terms in order. And this formula here is telling you, if you want to know the next term in an arithmetic sequence, then add d to the term before it, which we know that already. I mean, you already know this, right? To find the nth plus 1 term, add d to the nth term. If you want to find the 5th term, you add the 4th term plus the common difference. If you want to find the 20th term, then add the 19th term plus the common difference. That's all it's saying. These are just two terms in order. Same thing with the geometric, right? An plus 1 is an, the term before it, times r, right? So if you know the first term, you can find the second term. If you know the second term, you can find the third term. In general, if you know any term, you can find the next term. That's what that says. So I got one more example, then we're done. And there's some homework like this too. That's why I'm putting it in there. Write an explicit and a recursive formula for the sequence. Now, I didn't tell you what kind of sequence this is, so you're going to have to pick the right kind. What kind of sequence is it? Is it arithmetic or geometric? It's arithmetic, right? So when it says write the explicit formula, in your mind, you've got to be going, oh, that means an equals a1 plus n minus 1 times d. And the recursive formula, an plus 1 equals an plus d. Right? All we need to fill in for on the first one is the a1 and the d. And on this one, just the d. That's all you have to fill in. So looking at these here, right, what's the first term? There's the a1. And what is the d? Right, d equals 6. So if I plug into this formula, an equals 0 plus n minus 1 times 6. An equals 6n minus 6. And how about this one? An plus 1 equals an, that part never going to change. Always the same, right? And then what comes after? Plus 6. Done. You know, I know you get confused by all the n's and n+1s and subscripts and all that. But the more you see it, the easier it'll become. But like I said, most of the time when if you're asked for a formula, find a formula for the nth term. That's not talking about this one. That's talking about this one. Right? You good? Bergen? You good? And so go ahead. Yeah, I might as well do it. Write an explicit and recursive formula. And it's an arithmetic again, so. Did you get it? What did you say? You gotta simplify. Simplify that. You got everything plugged in right, just simplify now. Distribute.
Okay.
It actually simplifies pretty easily. -4. Yep, both are right. Did you get it, Shane? Let's see. That's correct. But are you really adding 4 to get the next term? Yeah. Yeah. You got to combine like terms. Come on. -4 plus 4. You're not going to leave that. Again, in this one, what was the A1? That's easy. I almost hate to ask that question, right? What is the D? -4, right? These numbers are getting smaller. So again, if you do the difference, you could say the second term minus the first. -8 minus -4, which is -4. So that's D. So AN equals -4 plus n minus 1 times -4. Distribute. AN equals -4 minus 4n plus 4. So AN equals -4n. And you know, when you do that kind of thing, you should always just check it. Does it make these terms? If I start plugging in n equals 1, do I get the first term? And n equals 2 and n equals 3. I mean, you can check it yourself, right? If it doesn't make the terms in the sequence that you started with, then it's not the right formula. And then what was the recursive? AN plus 1 equals AN plus -4 or -4. Either one's fine. Yeah. -4 plus 4. They cancel. Okay. Clear as mud? So that's it. You know, when we read this at the beginning, you wouldn't have understood a lot of these terms. But now when it talks about explicit and recursive formulas and terms, arithmetic, geometric. So I'm going to come around and sign the U tries right now. That's the homework.